This is section 7.4 in your textbook, page 366. We're talking about the sine and cosine ratios. We did learn the tan ratio first. The reason we learn the tan ratio first is typically when you're dealing with problems, word problems or problems outdoors, is usually you can relate, if you think of a triangle like this, okay, it's kind of like a ramp. Typically it's easy to measure these two, or maybe think of it as like a tree. Okay, and typically you see like the shadow of the tree, and you want to know something about the height of the tree. Okay, so we get this sort of triangle happening, and the hypotenuse is kind of the unknown. It's kind of in space. It's hard to measure from this point up until another point as high as the tree. So that's why they talk about the tan ratio first. The way I learned it in school was the sine ratio first. Because we kind of think of, when we think of the rhyme, we think of Sohcahtoa. Okay? And we always have kind of sine first in the rhyme, and typically the way it used to be taught in school was sine was taught first. And when we look at trigonometric ratios later on, sinusoidal curves is the one you look at first. Okay, you'll see that in grade 11. And then tan curves look really, really strange, and so they're not looked until quite after we look at sine and cosine. So we have this book, the textbook, this particular textbook kind of looks at it a little bit backwards in a sense, but the reason is because of this. Okay, they want to kind of give you a practical use for these trigonometric ratios, and tan is one that's kind of more immediately practical. So that's the reason why we look at tan first. But the other two ratios, sine and cosine, are very similar, and the process for answering questions is very similar, as you guys have probably already seen now. Okay, so I'm just going to show a couple of examples. So first and foremost, this is the kind of thing you need to remember, Sohcahtoa. So Sohcahtoa stands for sine theta is equal to opposite cos theta is equal to okay, this word is coming up again for cosine, adjacent. Who can tell me what that word means? Lucas, you remember?
If it's right next to it?
Yeah, next to it. Good. So that's what adjacent means. It comes up again for cosine. Opposite we know, and hypotenuse we know. So moving forward, I'll expect you guys to use, you can use point form. Okay, so op means opposite, hype means hypotenuse, ADJ will stand for adjacent, and tan is opposite over adjacent. So you can use those abbreviations moving forward. And sine, they break down, they lose the E, and it's just sine. Steven.
On a test or the exam, do you want us to put the abbreviations then plug in, or can we just plug in right away?
You can plug in right away. If you do mix them up, though, there's a chance, depending on the question and what it's worth, there's a chance I could give part marks for this. So not a bad idea, because you could always put down the correct formula and then miss when you go to substitute in, right? So it's not a bad idea to put this down, but again, it's depending on how much the question is worth. If it's worth 1 mark and you miss it, then you're probably not going to get any marks anyways. Okay? All right, so looking at a couple examples here. First of all, primary trigonometric ratios. That's what these are called. Sine, cosine, and tangent. They're called the primary trigonometric ratios. We call them the primary because we're going to learn about 3 other ones that are secondary trigonometric ratios. Okay? And they're kind of the inverse of these, or they are the inverse of these, and you'll see them. Okay, cotangent, secant, and cosecant. Okay? I'm not sure what section we'll cover that in, but you'll see that. It's just going to be the inverse of these. They're often abbreviated as sine, cos, and tan. And so now a typical problem you'll have, find the three primary trigonometric ratios for theta. Again, we talked about why we use theta. Anybody tell me what theta is and why we use it? Talked about this with tan. Gianluca? Yeah, it's a variable like any other. It could be a letter. It could be used as a letter. Luigi, do you know?
Greek letter.
Yeah, it's the Greek letter what?
T.
Yeah, Greek letter
Tau or something.
T. Oh, it's theta. Okay, and it's used for angles. Used for unknown angles. Okay, and you've probably already seen though that some angles we even represent as x. Okay, so you might see that on a test as well. So if theta is our unknown variable, we're looking for theta. The trick now becomes not so much the math of what to do once you have the ratio, but which ratio am I going to use? Okay, so this is what you got to decide. This is the hard part. All right, it's deciding, am I going to use sine, cosine, or tan? You got three choices. So the way you figure that out, the first and foremost thing you need to do is identify the angle. Okay, because on the test I'm not going to tell you. I'm not going to say use tan ratio to answer this question. You're going to have to decide. Okay, and in some cases you could use more than one, depending on what information is given. The first thing you always need to do is identify the angle we're talking about. Okay, because if we identify this angle, then everything is going to be mixed up. Everything is going to be backwards. Because this side is now opposite this angle. Whereas for this angle, this side is adjacent. That's the biggest trouble people have, is they want to call one side opposite side all the time. But it's not. It's all dependent on what angle you're looking at. So if we decide that this is the angle we need to find information about, you look now at the triangle, see what other information you have and what you need to find out. This says find the three primary trigonometric ratios for theta. We have all the information we need. So we can just go ahead and plug that information into our ratios to figure out what they are. So sine theta is opposite 10 over 26. Cos theta is adjacent over hypotenuse. So 24 over 26. And of course you would reduce this to lowest terms. Okay? So 10 over 26 is going to be 5 over 13. This is going to be 12 over 13. Don't forget to do that because that needs to be reduced. Just like any problems, you're going to reduce the lowest term. And finally, tan theta is going to be opposite over adjacent. So 10 over 24. Which is 5 over 12. How could I find out what this angle is then? Can anyone tell me? Michael.
You apply that and then you multiply by -1.
Yeah, no, you don't multiply by -1. You remember? No? Steven?
You have to do tan -1 times whatever ratio you have.
Yeah, so it would be the inverse function of each one of these. So cos inverse times the result of that. Okay, so the way I could show that is the answer for the angle would be theta is equal to cos -1 of 12 over 13. Okay? It's also going to be equal to, theta is equal to sine -1 over 5 over 13. Can everybody do this on their calculator and just make sure that this angle that you're getting, that angle should be the same every time, okay? Even though you're using different ratios, it should always be the same. What is the angle?
22.6.
22.6? And you get that for all three, right? That's very important that you guys understand that even though you're using different trigonometric ratios, the triangle is drawn properly to scale and you have these sides and they're all correct, they'll all give you the same angle. Okay? Yeah.
You have to round it to 1.
It depends on the question. It'll say round to the nearest degree. Okay? This one, I don't think it said anything. So if it doesn't say anything, I would usually keep 1 decimal for the angle, and I would keep 4 decimals for the side length. Okay? All right, next one. So the 3 primary trigonometric ratios with theta here. So sine theta is opposite, which is 6.4 over hypotenuse. Cos theta is adjacent now, 4.1 over 7.6. And tan theta is opposite, 6.4 over 4.1. Any questions there? I think that's pretty straightforward. Let's get into solving a couple angles now. Alright, so this just says evaluate the following to 4 decimal places. So sine 26 degrees. You can tell me what that is. 4 decimal places. Make sure you take the 5th decimal place and round the 4th. Luigi.
0.4384.
Okay. Guys, I'm not doing this for my benefit. This is for you guys. So please make sure that you can do these simple calculations with your calculators, because that's what a big part of this section is just being able to use your calculator. Yeah.
0.2588.
Okay. Good. And we're going to look at a word problem now. We're going to have Alan. Can you read on 369? Captain Jack.
Captain Jack is navigating his ship to Port Harbor, which is directly north of the ship's location. To compensate for an easterly current, he aims for a point on shore that is 5 kilometers west of Port Harbor. Assuming that the point on shore is 20 kilometers from his position now, at what bearing must Jack head his ship?
Alright, so we get this triangle here with Jack navigating. We have a triangle that says, assuming that the point on shore is 20 kilometers from his position, which is this distance, at what bearing must Jack head his ship? So we wanted to find out what this angle is, right? Bearing is actually the angle from north, so it's the clockwise angle from north. So if we can find out this angle, we'll do 360 minus this angle, and that will give us this angle, which is his bearing. Alright, so if we label this theta in here, who can tell me what ratio we're going to use? Just 2 people?
Sine.
Sine, okay, so you're saying opposite over hypotenuse. I'd agree, good. So sine theta is going to be equal to 5 over 20, which is also equal to 1 over 4, right? Sine theta. Theta is going to be equal to sine inverse of 1/4. Which is 14.477 degrees. So if we were to say straight bearing, bearing is always measured from clockwise from north, so it would actually be 360 minus, say, 14.5 would be equal to 345.5 degrees. That would be your bearing. They list the bearing as north 15 degrees west. Okay, that you can also say it that way, which is saying that they're going 15 degrees. They're going north first, 14.5 degrees west. But this is actually a little more accurate. That's the official bearing. Because bearing, as as pilots know bearing and military know bearing, it's always clockwise from north. Alright, B says, Captain Jack is in communication with a submarine that is cruising at a depth of 400 meters below sea level. If Jack's radar tells him that the submarine is 500 meters from Jack, due north of his ship, at what angle is the submarine located with respect to Captain Jack's ship to the nearest degree? So, we're looking at the surface of the water here. This is where Captain Jack is. We have a submarine, let's say over here. We have to say north is this way. We can't say north is up because that's the third dimension, right? Up is the sky. So north is actually straight ahead if Jack is traveling in this direction, right? So this is north. So your submarine is down here. We can create a triangle like this, where we know that he's 400 meters below and he's 500 meters away. We know that's 90 degrees and that's the angle we're looking for. So it says, at what angle is the submarine located with respect to Captain Jack? So we're looking for theta here. So which trigonometric ratio are we going to use? Ace. Cosine, good, because we have the adjacent side and we have the opposite side. So we're going to say cosine theta is equal to adjacent 400 over hypotenuse 500, which is the same as 4 over 5. So to solve for that, we say theta is cos inverse 4 over 5, which is equal to, yeah, Sebastian?
36.9.
36.9 degrees. All right. And we'll do one final example here. This is example 4. It says solve ABC, round side lengths to the nearest unit and angles to the nearest degree. So you will see this question quite often. You'll see it on the quiz, you'll see it on the test. When it says solve, can anybody tell me what it means by solve a triangle? Tiago.
Find the side lengths and find the angles.
Yeah, not just the side lengths of the angle, all of them, right? So when you solve a triangle, you're identifying all the side lengths and all the angles. So in other words, we got to find x, we got to find, let's call this h for hypotenuse, we have to find theta, and that's it. Okay, we have 3 sides, 2, 3, and we have 3 angles now. Obviously, you don't have to find the right angle because we know it's 90. So where do we want to start here? Solve this. You don't have to start at the same spot. Daniel.
Find the inside angle,
Okay, what's that called?
that's theta.
Good, theta. So how would you do it?
You do 90 plus 30,
Okay.
and then you take away that for 180.
Excellent. 180 degrees minus 120 degrees is 60 degrees. Good, that's one way we could have solved it. Let's look at another way, okay? Let's just say we didn't know this. Is there another way we could solve it? Actually, it doesn't look like there is there? There's just not enough knowns. Andy?
If we had another side.
Yeah, if we did, but at this point we don't. Let's find a side first then. Let's not worry about this. Let's see. So what side can we find? Luigi?
Well, I was gonna say, since you already have 2 angles, can you just subtract?
Yeah, that's what he did.
Oh,
That's what he did. Yeah.
Oh.
Yeah, okay, let's find the hypotenuse then. Which trigonometric ratio? Sine. So we're going to say sine. No, not sine,
Cosine.
because x is unknown, right? So cosine of 30 is equal to adjacent, which is 20 over h. So h, these switch, is 20 over cos 30. Okay? But just to show why these switch again. Okay, I want you guys to be comfortable to do that. But I also want you to understand why it's happening, right? So like, if I were to do the long method, I'm gonna put h here, so I'm multiplying by h. So now we have h cos 30 is equal to 20. Now I'm gonna divide both sides by cos 30, divide by cos 30. These cancel, and I'm left with h equals 20 over cos 30. Okay, you guys see that? You understand why these can just switch places now? That's the long method, and you end up with this. What's the answer to this? What's h?
23.
Yeah, 23.1.
23.1?
Yep.
Okay, so now we have h, which is equal to 23.1. Let's just confirm this angle now. I think we can get this angle now. So if I use opposite over hypotenuse, so I'm going to use sine. So sine theta is equal to 20 over 23.1. Theta is going to be sine inverse 20 over 23.1, which is what? Nicholas?
59. Oh, 60. If you round it.
59.9, so these are the same. Just wanted to show you that you didn't need to minus the angles, although this is the preferred method, right? Daniel's way is quicker, and it is probably more accurate as well. Slightly. This is rounded, it should be correct. The reason why it's not exactly is there was some rounding done here. Okay? Last one. We have h, we have theta, we just need x. So which ratio? Yeah?
I was going to say you could also use the Pythagorean theorem. for
You
that.
could, yeah. But do we want to use that? No, it's a lot longer, right? This is a faster tool. Yep.
Use cos.
Okay, we could use cos. See, I personally, you could use cos because you have theta now. So you could say this over this. But I would use sine. And the reason why is just because there's no rounding that would have been involved in finding this angle. See how you would have been maybe slightly off at 59.9 for this angle? If you use what was given originally, so we use sine 30 degrees is equal to x over hypotenuse 23.1. Now we're only using one value that could have potentially been rounded. Okay? So x is going to be equal, these switch places, sine 30, 23.1. What's that?
$11.55.
547.
11.55. Or 547? Yeah, 4 decimals typically for side lengths. 47 what?
0 to 0.
Good. Any questions there? So, our key concepts, we have 3 primary trigonometric ratios, which are here. You can find any side length or angle, measure of the right angle. If you only know 2 pieces of information, that's all we need to know. We started with 2 pieces here. It does not matter, or sorry, should I say doesn't matter, what 2 pieces they are. Do we need at least 1 side length though?
Yes.
We do, right? We can't just have 2 angles. Because if we have 2 angles, we don't know the scale of the triangle. So, you could have a triangle like this, know it's a right angle, and say this is 40 degrees, and this is 50 degrees. Well, that's 2 pieces of information, but we don't have a side, so we can't figure out any other side. So you need 2 pieces of information, but one has to be a side. Okay? All right, that's it for 7.4.